picture. All right, maybe something like, oops, fx, x, and do this. Fill that in maybe, and then something like this. All right, again, since there are arrows at the ends of this function, right, the left end behavior is heading towards infinity, the right end behavior is towards negative infinity. Therefore, there can be no absolute max, no absolute min, because it goes on forever in both directions. But relative extrema it does have again. So let me label here, I'll label this A, and I'll label this B. So around A, I can construct an open interval, which maps to another open interval of function values, and clearly there is a relative minimum here, okay, along this locale of function values. So therefore we have a relative min at x equals A. Minimum at x equals A. And again, at this relative minimum, the main point I'm trying to make here is, in the picture you see that the tangent line would be slope 0. Okay? Just like before for that relative maximum in the previous example. So tangent line has slope 0. Therefore, f prime at A is 0. So again, the derivative being 0, extremely important for thinking about certain types of relative extrema. All right, now we look at this discontinuity here. Is there anything going on here? So if I take an open interval, never matters how wide or how narrow or how asymmetric, it doesn't matter. And I map it to the function values going on here. Okay, so I'm looking at this set of values, and then down to here. That's what we're looking at. An open set of range values. All right, on that interval of range values, the red interval there, is there a highest or lowest value? The answer is yes, there's a highest, right? And it's happening right here. I can't say there's a lowest, again, because whatever you would posit here to be the lowest value, or here to be really over here, I guess, to be the lowest value, it doesn't contain this this endpoint here, so therefore you can always get lower and lower towards this endpoint without ever reaching it. So therefore there is no lowest value on the red interval. There is a highest value right here at this this point. Okay, so what's going on there with the derivative? So we have a relative max at x equals b in this case. What does that mean for the derivative? Well, in this case, it's a very special case, f prime of b is, well, it's having a discontinuity, right? And if a function is discontinuous, automatically the derivative does not exist. Okay? So like the last one, which was a cusp, right? The derivative did not exist. Now you have a discontinuity, but there's still a relative extremum happening there. It just happens to be a different geometric situation, right? It's a discontinuity. So again, we see the ideas of derivative equal to 0 and derivative being undefined being integral to the idea of relative extrema.